Hi students, I am Dr. Uma Megeshwari from JJ College of Arts and Science. Now we have discussed about the stochastic process for first year MSc Mathematics in the unit of 4 renewal process and theory. Okay, what is renewal process? Let xn where n equal to 1, 2, 3, etc. be a sequence of non-negative independent random variables, and we choose the initial value s naught equal to 0 and Sn, that means sum of n terms x1 plus x2 plus etc. xn where n greater than or equal to 1, and consider the random variable n of t equal to supremum of n where Sn less than t, which is called the renewal process, with the distribution capital F where fn of x equal to probability of Sn less than or equal to small x. So these are the renewal process examples. The first one is the lifetime distributions of a component such as the electric bulb, which is either works or fails completely. Okay, so the lifetime of the electric bulb which is suddenly fails or works completely. And another example is consider the production of a certain component in the batches in an industry. Immediately on completion of production of batch, that of another batch is undertaken. So next batch up to come, we finished the first batch production. Okay. So and next the renewal. What is renewal? Suppose that we are interested in a certain outcome in a trial or pattern of outcome in a number of trials. We denote the renewal event by E star. So we want to the outcome. For example, we achieve the goal. Okay, so we achieve the goal, then we try until the success. So that is the renewal, and it is denoted by the E star. Okay, renewal period, the interval between the occurrences of two successive renewal, which is called the renewal period of the process. Okay, the intervals between the two successive renewals, which is called the renewal period of the process. And next the renewal function, it is denoted by m of t, where m of t which is equal to expectation, it is the e of n of t. So this is called the renewal function of the process. Next definition is a persistent renewal event and transient renewal event. Let E star be the renewal event. We define Fn and Pn as follows. Fn is a first time, that is we know that F is a first meet. Okay, so Fn equal to probability of E star occurs for the first time at the nth trial, and Pn is a probability of E star occurs at the nth trial. Okay, so in Pn repetition is allowed, Fn no repetition allowed, that is the first time entrance is a Fn. Okay, and define the initial conditions for f naught equal to 0 and the probability p naught equal to 1. This is known, already known, that is the initial conditions for f naught and p naught. Okay, and next we defined f star function. F star function is nothing but summation of fn, which is a probability that the renewal E star occurs at the some trial in the long sequence of trial. Okay, so we have f star is less than or equal to 1. Suppose f star equal to 1, then the sequence fn represents the distribution of the length of the renewal period t, then p of t equal to n equal to fn, and f star equal to 1, then the renewal E star which is termed as a persistent. Suppose f star value is less than 1, then it is called as a transient event. Next book work, that is a relation between the f of s and p of s. or which is called for the find the relationship between the probability generating function of the renewal occurrence for the first time at the nth trial and the renewal occurrence at the nth trial, not necessarily for the first time. Okay, so proof of this theorem is, by the definition we know that F1 and Pn, F1 is a first time at the nth trial and Pn is occurs for the nth trial with the initial conditions of F not equal to 0 and P not equal to 1. Okay, and f of s is nothing but which is equal to summation of n equal to 0 to infinity fn s power n, and p of s is nothing but summation n equal to 0 to infinity pn s power n. So we put the initial condition n equal to 0, then we have a p naught s power naught. P naught, we know that the initial value p naught equal to 1, therefore 1 plus summation n equal to 1 to infinity pn s power n, which is denoted by the equation number 1. And next, the renewal event E star occurs at the nth trial may be the compound event such that E star occurs for the first time at the rth trial, and again the lateral trial which is denoted by the numbers n. Okay, so thus we pn equal to summation r equal to 1 to n fr pn minus r, which is n greater than or equal to 1. This is the equation denoted by 2. Next, this equation is multiplied by s power n. Both side we multiply by s power n. Okay, so multiply by s power n. And next term, s power n split up into two terms, that is s power r and s power n minus r. Now consider the term s power r combined with f of fr and s power n minus r combined with pn minus r. Okay, so that is the next step. Next, the pn s power n, which is equal to, expand this term for r equal to 1 to n, we get the value f1 of s pn minus 1 s power n minus 1, f2 s square pn minus 2 s power n minus 2 plus etc. fn s power n p naught s power naught. Taking the summation from n equal to 1 to infinity on both sides, then we get summation n equal to 1 to infinity pn s power n, which is equal to f1 of s summation n equal to 1 to infinity pn minus 1 s power n minus 1 f plus f2 s square summation n equal to 2 to infinity pn minus 2 s power n minus 2 plus etc. Okay, and in the summation n equal to 1 to infinity pn s power n is denoted by p of s minus 1, which is, how is it write this equation, because the equation number summation n equal to equation number 1 summation n equal to 1 to infinity pn s power n is p of s minus 1. So which term is here mentioned by p of s minus 1, and consider the term f1 of s f2 of s square plus f3 of s square into summation n equal to 0 to infinity pn s power n. Okay, and f1 of s f2 of s square etc., which is denoted by summation n equal to 1 to infinity fn s power n, and this term is denoted by summation n equal to 0 to infinity pn s power n. This term is denoted by p of s, this term denoted by f of s. Okay, finally we find p of s equal to 1 by 1 minus f of s, and f of s is equal to p of s minus 1 divided by p of s. This is known as the relationship between the f of s and p of s. Thank you, students.